Yeah, somebody's playing some games or doing texts or something.
It's not the game. It's the Google Hangouts thing, and they're probably texting with somebody on Google Hangouts.
Okay, thank you, Alexander. And nobody texts during this class. Okay, that's really, really important. Okay, because we all work really hard and we want to focus for just 60 minutes, 3,600 seconds. And I think we can handle that together. Now, hi, Hannah. How are you? So guys, last week we started looking at the game Kakuro. And what was really fun about the game Kakuru is that we had to look at something called restricted sets. So restricted sets were when I said to you guys that we had two boxes that had a sum of a particular number, and we can only use the numbers 1 through 9. There were some that only had one combination. Does anybody remember the 4 numbers that had only one combination and 2 permutations? Remember, permutations are the number switched, okay? Whereas combinations are just the numbers we're talking about. So Adalia?
4 plus.
So we had 4. Someone else? Someone else, another one? Where there was only one combination? Go ahead, Luca.
There was 3.
3, and John?
2 divided. Oh wait, no. 1.
Well, 1, we could not have 1 because we don't have a 0.
1 minus.
We were not allowed to use minus on this one. And Hannah? Any ideas? Hannah, you're behind your name, so I thought maybe you were raising your hand. If you can maybe angle the computer down a little bit, then I could see you. I'm gonna go Antares. Do you remember the other numbers? Or David, or Luke, or Jesse, or Rafa? And nobody knows the other numbers. Okay, go Claire.
16 and 17.
Very good. Very good. All of those had only one combination. What was the combination for 3? Everybody say it.
2 and
1 and 2.
1 and 2. Combination for 4.
2 and 2.
2 and 2.
1
No,
and 3.
we were not allowed to use 2 and 2. The combination for 16.
9 and
9 and 7.
7 and 9. Combination for 17.
8 and 9.
8 and 9. Now, so combinations are the number of ways to take a certain number of items from a population. So we had 9 items, but we had we wanted to take 2 items from a population of 9. And we knew that with the numbers 3, 4, 16, and 17, there was only one combination. But why do we say that there were 2 permutations? So why did 3 have 2 permutations? Who can describe why 3 had 2 permutations, but only one combination? Anyone want to take a shot? I'll go with Luca.
I think permutations. It also counts the different ways it can be assembled.
Yes, the order matters in permutations. So Andres, can you give me the 2 permutations for 3? And Jesse, I'm going to call on you next.
3. 2 and 1 and 1 and 2.
2 plus 1 or 1 plus 2. Jesse, what about 4?
It's 1 plus 3 and 3 plus 1.
And whoops, 3 plus 1. And what about everybody say 16? Go.
7, 9.
7997.
9, 9, 7.
And of course, 17.
9 and 8.
8, 9.
All right, very nice. Now, what about 3 numbers? What happens if we have a set of 3 numbers? Do you guys remember what the restricted sets were for 3 numbers? Again, there were only 4. I am not looking for permutations. I'm only looking for combinations right now. So these were, and I'm looking for John. Go for it.
6 plus
Say again, please.
6.
That is right. 6 is the first one. And the numbers, John, were?
1, 2, and 3.
Excellent. Who has the next one? Adalia, go.
24.
Ooh, 24 is at the other end. And what were those numbers, Adalia?
7, 8, and 9.
Beautiful. Who's got the other 2? Jesse?
I was going to say
I couldn't hear you. Your hands in front of your face.
I was going to say 7, 8, and 9.
Excellent, excellent, excellent. And who has another one? Come on, Alexander. I want you in this. Come on, Rafa. You're the puzzle man. Come on, Hannah. Luke.
Mr. Kramer,
Yes.
can I just, I forgot to get the packet and it's downstairs. Can I quickly get it?
You don't have to ask, my friend. You go right ahead. Like if you have to go to the bathroom or get a drink of water, you just go and you do it. Okay. Now, guys, John, do you have another one? Go, John.
I'm not sure, but 54 times.
Well, remember, these are all plus. This is Kakuru. It's
plus.
all plus. We can only use the numbers 1 through 9. And let's see. Do you have any ideas? David, what? Come on. Come up with an idea. Come on, Claire. Throw a number out.
15.
15. 15's kind of in between 6 and 24. And I'm going to just say 15. Let me see. 1. Come on, help me.
7.
5 and 9. Oh my God, guys, there's gonna be a lot for 15. So Claire, good one, but that's going the other direction. This one has the most restrictions. Okay, Dahlia, go.
7.
Okay, hold on a second. And Hannah, do you have another one?
I was going to say the same one.
But Hannah, use the same algorithm. If 6 goes to 7, then 24 goes to?
12.
23.
That's right. And so 7, everybody, is what? 1, 2, and?
4.
And 23 is 9, 8, and?
6.
6.
And guess what? Those are the only ones with restricted sets to 1 combination. Now, how many permutations? So everybody, let's do 24. Let's do 7 8, and 9. Everybody write down the permutations right now. You have 1 minute to write down the permutations. And it doesn't matter if you don't get finished, but just try your hardest.
Um, 16.
And if anybody has a good question that doesn't give it away for the other guys, you can ask that question. Hannah, go for it.
Yeah, no, I'll do it.
Please send our answers in the chat.
Oh, yeah. I'd love that.
I sent mine in the chat.
Good. Yeah, Dahlia. Oh, wow. Nice. Claire, Antares, Anna,
Oh.
Luca, and Adalia's actually giving me all the combinations. Jesse just gave, ooh. Guys, I'm sorry,
Yeah.
but I'm gonna have to go with Jesse's here. I gotta show you what he did. Hold on. I'm gonna see if I can. Okay, guys, check this out. So Jesse writes out the combinations, and I just like what he did. The reason why I like what he did is he did what a can you guys say combinatoric?
Combinatoric.
Yeah, he did what a combinatoric mathematician would do. He started out with 7, 8, 9, and then he switched the last two to 9, 8. Then he went with 8 as the first number. But of course, he then went in order, which was very good. Hold on a second. I want to give a better view. He went with 8 and then 7, 9 and 8, 9, 7. Now the next one, he went out of combinatoric just slightly. He went with 9, 8, 7. I would have gone with 9, 7, 8. Doesn't matter. It's the same thing. And then 9, 8, 7. And this way you know that there are 6 permutations for 3 numbers.
I got 6.
And a lot of other people also got 6, which is very, very cool. Now, I want to pose this question to the group. Which number, hold on a second. Wait a minute, where are we? 24, 3 numbers. There we go. So we know, guys, that the numbers we're dealing with, go to page 8, please, only. That we know that 6 and 7 had the fewest combinations. 23 and 24, all of those had only one combination. They had the most restrictions. Which number is the worst number for Kakuru, but the best number for combinations and permutations? Which number do you think? Antarisk, what's your thought? And I want everybody calculating. Antarisk, you raise your hand. I'm calling on you. Okay. Anybody else? I want to hear, and I want to hear why you came up with this. So Jesse?
I'm actually, I'm still thinking why I came up with.
Okay, okay. And what about you, John?
24 because it's the biggest, and if you're using lower numbers, then it's harder to like add up to the numbers.
But John, we know that 24 and 23 and 6 and 7 have the fewest combinations and permutations because they've only got one combination. We've already determined that. So my question is, which one has the most combinations, not the fewest? We're going to go with Hannah, and then we're going to go with David, and then Claire and Adalia. Go.
17.
17, and go David.
10.
10, and go Claire.
I was gonna say 10 too.
And then go Adalia, and then Luke.
Mine wasn't a guess. I was just wondering if it's 3 numbers or 2 numbers.
Actually, it is 3 numbers, but I don't want to give it away, but that's a good question. Luke?
Well, I have a question. Wait, so what are restrictions again?
Okay, so for instance, there are the most restrictions on the number 6 because the number 6 with 3 sets can only be one group. You can't have, so it's got the most restrictions and the fewest combinations, Luke. We are looking for one with the least restrictions and the most. Hannah?
Oh, I get it. My answer because I thought it was only 2 combinations.
I don't agree with the answer of, I don't agree with the 2, but I like to hear your amended answer.
I haven't actually decided yet, but
Okay, good. And then Luca?
15.
I couldn't hear you, my friend. Say again.
18 and 15.
Yeah, Luca, first of all, unmute yourself. You got to get a better internet spot in your house. And maybe you could chat it to me, Luca. If you chat it to me, maybe that's the best way because your voice just always gets jarbled for some reason. Adalia.
9.
Louder, please.
9.
9. Okay, I've got 9. Anyone else?
Also, I think he said 14 or 15.
Ah, interesting. Now, guys, I'm going to go back to the chats here and see if he's put anything more in the chat. And, now it's interesting. Luca gave me 3 numbers, 13, 14, and 15, and I do not agree with all of them. John.
19.
Now, guys, your numbers are kind of all over the place. I want to ask you about something called balance. If 6 and 7 have one combination and 23 and 24 have one combination, where do you think the location would be of the one that has the most combinations? Claire?
In the middle. So 14 or 15.
No.
I'm not sure which.
Only
15.
the number 15, guys, is called the median. 15 is the median number between 7 and 23. And the numbers surrounding that are 14 and 16. And they will have the most combinations. So I want everybody right now to go to another page, and I want them to do the combinations for 15, then 14, and then 16. Remember, we're talking 3 numbers. So 1, 9, and 5 is the first one. And by the way, you can choose to do 15, 14, or 16.
Wait, so
You don't have to do them in that order.
they're only addition, and can there be any numbers to add up to them? Or
1
just 1
through
through
9.
9?
1 through 9 and no repeats.
Up.
So for 14, I would start with 1, 9, and 4. For 16, I would start with 1, 9, and 6.
Wait.
Wait, Jesse has a question. Go, Jesse.
So for this, do we write down the permutations?
No. Just write the combinations. The permutations would take you way too long. Remember, there are 6 permutations for every one of these.
Oh.
So you don't want to do the permutations. You want to just do the combinations.
Can I do like if I were say, or if I were to do say 15, could I do 6, 6, and 3?
No, you can't. Like you can't do 5, 5, and 5 because the numbers repeat. And Luke, what you want to do, Luke, is you next want to do 1, and then 8, and 6. You see the pattern. Follow a pattern and you'll never miss. Think of what Jesse did when he did his 7, 8, 9.
Yeah.
And he was doing the permutations. This is a little harder because the numbers are different. And if you have a good question, ask that question just like Jesse did, and just like Luke did, and just like I think Claire did also. Wow, everybody is working so well. I love the diligence. I'm going to go to the restroom real quick. I'll be right back.
Hold on.
Okay, I am back. Who's got questions and who's ready to share? Who's ready to share their combinations? Has anybody completed one of the numbers?
I'm almost done with 15.
Okay, cool. And Rafa, which one have you completed?
14. I think I got all of them.
Okay, Rafa, let's see if you can do it in a combinatoric method.
Like the way Jesse did.
Yeah, go for it, man.
I didn't like that, but I'll rewrite it.
Well, no. You tell me. I mean, remember, the next one for 14 is going to start with a 1, but then these two numbers are going to have to add up to 13, but with the 8. And now you're showing it to me, but I need words.
Well, I did do it like that, and
So how did you do it?
I did it so I the first number I went from the one starting with 1 to the one starting with 2, then the one starting with 3, and then
Yeah. So
and then,
go 149, and what's the next one with 1?
and 158.
That's combinatoric. Keep going.
167.
167. That's perfect combinatoric. Keep going.
239.
239. Perfect combinatorics.
248.
248. Another perfect combinatoric.
257.
257. Once again.
329. We already did that because we did 239.
Right. So that's definitely a repeat. Can somebody help with 14?
347.
347. That works.
356.
356 is perfect. And is that it, Rafa?
I think.
Well, guess what? Rafa found all 8, and his combinatoric method was absolute perfection, just like Jesse's. Now, John?
I found one, all of them for 15.
Go for it, buddy.
So the two that you have, then 249.
249.
Then 258.
Perfect combinatoric.
267.
Magnificent.
348. 357. And then 456.
And John, why did you bypass a 3 and a 9?
What?
Why didn't you use one that started with 3 and ended with 9?
Because we already, because then the other one would have to be a 3, and we already have a 3.
That's right. That's right. Beautiful, beautiful job. Has anyone done 60? Luke? And you'll have to unmute yourself.
Yeah, well, there was just some stuff in the background. I have not done 16, but I found some more for 15.
Oh, please, please.
I have 438.
438.
Oh, you can't. Okay, never mind.
Now wait a minute. Wait a minute, Luke. 438 is another permutation for the 348 combination. You understand? So there are 6, guys. There are 6 permutations for each of the 8 combinations. So who can tell me what is 8 times 6? Say it out loud, please.
48.
And therefore, there are 48 permutations for every one of 15, 14, or 16. Now, has anybody done 16? Give me a thumbs up if you have. 1, 2, 3, thumbs up. Nobody. Wait, is that David? Have you started it?
Kind of.
All right, so David, come on. Everybody help me with David. Ready, go.
I found 5 equations.
Wait, say again, Claire.
I found 5 equations, but that's it.
Oh, for 16?
Yeah.
Well, honey, give me the 5 that you found.
169, 178, 295, 286, and 367.
And what about 3? You see, if I'm using combinatorics, Claire, do you see how I always start with the smallest and the highest? What number belongs here?
4.
And then what about 3, 8? Come on, everybody
5.
can help. 5. And what about 3, 7?
6.
6. And what about 4? Come on.
5, 7.
4, 5, and 7. And guys, is that all 8?
Yeah.
And so you guys have completed it, and I'm very, very, very impressed. Now, the next question and the next challenge. Here we go. I'm now going to look at the sets for 4 numbers. And I'm actually just going to give a blank page because I don't want to give it away. If we have a set of 4 numbers, what are the 4 numbers that had the restricted sets where there was only one combination?
6, 7, 23, and 24.
That is true for the 3-digit sets. But please raise your hand. So that's true for the 3-digit sets. We're now talking about 4 digits. So Luca, start us off, buddy.
30 and 10.
Well, let's see. 30 and 10. So I'm going to go with 10 and I'm going to write down 30. Now, what are the numbers that make the 30?
9, 8, 7, 6. Or 6, 7, 8, 9.
Now, when you guys, does that equal 30? Yep. And Alexander, can you give me the numbers that add up to 10, please? And Alexander, you're behind your name. If you can angle your computer down, then I could see you.
6 and 4.
Well, that's true if there were 2 numbers. Come on,
Yeah.
dealing with a 4-digit.
3. 2, 1, 4.
Of course, 1, 2, 3, 4. Now, who can think of the other two? Who can think of the other two using the same algorithm that we've been using here? Hannah, what do you think, honey?
29 and 11.
20, of course, 29 and 11. And Claire, do you have the digits?
For 11, it's 1, 2, 3, and 5. And for 29, it's 5, 7, 9, and 8.
And guys, that is a thing of beauty. Now, I am going to ask this question. Remember, there's only one combination here. Which numbers have the most combinations? And what I'm going to do is I'm going to give you a new page, and this page has the numbers listed out from 12 to 28. What are the 3 numbers that you believe? And John can see it right away. Don't say it out loud yet. Rafa's got it. Claire's got it. Adalia's got it. And I want to hear it from everybody. So just everybody think. Alexander, I want to make sure I can see you. You're still behind your name. And all right, guys, say it on 3. 1, 2, 3, go.
20.
20.
20, 20, 19, 20, 21.
And I like the 3 because we've always had a set of 3. 1, 2, 3, 4, 5, 6, 7 to the left. 1, 2, 3, 4, 5, 6, 7 to the right. Now, what we're going to do first, before we do anything, is find out how many permutations there are for a set of 4 numbers. But guess what? This time, we are not going to write them out because it would take you too long. You remember that when we had 3 numbers, there were 6 permutations. Now, hold on. Now we have 4 numbers. Who has an idea of an algorithm we could use to figure this out? I'm going to go with Claire and then Adalia.
I was going to say 12, but I'm not sure if that's right. So for 1, it can be in the first square 3 times, because then it can be 2, 3, 4, 2, wait.
So Claire, think about it, write it out.
Wait, no, I think there's 24 combinations.
4. And Adalia and Luca, what do you think?
I also think there's 24 because 4 factorial is 24, and you said earlier that you had to do that was how you found it.
Now, guys, do you guys agree that 3 times 2 times 1 equals 6?
Yes.
Do you agree that 4 times 3 times 2 times 1 equals that number 24 that Claire and Adalia and Luca came up with? Yes?
Yeah.
Now, do you remember last week when we looked at that that row that was 9, that was a column that had all 9 numbers and it added up to 45? Do you remember the number that I told you?
Yeah.
It was 9 factorial, and I think the number was 362,880 permutations.
Wow.
But 4 factorial is only 24. Still a big number. So now we're going to do 19, 20, and 21. We're going to do 19, 20, and 21. You're allowed to choose either one you want, By the way, I'm going to write out the 19. I'm going to write a 1 and a 9, which makes 10. And I need 9 more. So I'm going to write a 2 and I'm going to write a 7. So 1, 2, 7, 9 is my first combination. 1, 2, 7, 9, thinking like a combinatoric mathematician. And I want you guys to be the same. And I'll give you a push on each of these. Guys, it's going to get more complex as you go. And if anybody has any questions, I thrive on good questions. Some people thrive on eating well and drinking water. I thrive on great questions.
How many combinations are there for every number?
Say again.
How many combinations of numbers are there for every number?
Ah, great question. I don't want to give that away just yet because I think you guys should find that out on your own.
Really?
But I do like that question a lot. Six. All right, guys, let's take a break. We've got 4 minutes left. Now, did anybody find all 12 in the 20? And I'm not sure that mine are correct. So I believe there are 12 combos.
2, 3, 4, 5, 6, 7, 8, 9. I got 10.
For which one, John? For 20?
Oh no, I got 10 for 19.
Well, I think 10 might be the right number for 19. John, do you want to give them to me really fast?
Sure. So the one that's there, 1, 3, 7, 8, 1, 4, 6, 8, 1, 5, 6, 7, 2, 4, 6, 7. 2, 3, no, 2, 5, 4, 8. 2, 3, 6, 8.
Wait. 2, 5.
4, 8, and then
And what was the next one?
2, 3, 6, 8.
2, 3, 6, 8.
And 2, 6, 7, 4.
Got that one here.
Oh, then X that one out. 3, 7, 5, 4. 3, 4, 6, 7. Oh wait, no, that's wrong. Never mind. There's only 8.
Yeah. And John, do you see how beautiful your combinatoric method was for the ones? And then
Yeah.
do you see how when you got into the twos, you started with 2 and 4, then you went 2, 5, then you went down to 2, 3. They've all got to be in this order. And that's, so I think, like, if you think the way you did with the ones, you'll be successful with the 2s and 3s. Anybody else try 21? Anybody else get more than 8 for 19 or more than?
For 21, I found 7 combinations.
Okay, I'm going to tell you guys that there are, I think, 10 for 21 and 10 for 19. So your job this week is going to be to find all the combinations. But by the way, guys, if 20 has 12 combinations, how many permutations for each one? Come on, how many permutations for each one?
288. 288.
24. And so therefore, if you do 144, which is 12 times 12, and you double it, how many permutations does the number 20 have? 4. So say it out loud.
288.
And guys, that is a wrap. 4 numbers, literally 4 boxes, and you can have 288 different permutations for the number 20. Drop the mic. Drop.
Wow.
I found another one for 19.
Cool. And what's that?
2, 9, 5, 3.
Yep. So I would start with the 2, 9 for the 2s. And then I would say, oh, I need a, what number? An 8. And what were the other 2 numbers?
5 and 3.
Exactly right. And so that's the way I build it. Guys, gotta go. I've got another class. I'll see you in 167 hours.
Bye.
You are all
Bye.
combinatoric, and I thank you.
Bye.
Awesome job.
Bye.